Square roots. The product of two equal factors is the square of the number. So here's our equal factors, 5 and 5. That equals 5 squared, which equals 25. The side length of the square is 5 units. The area of the square is 25 units. And you can go ahead and count each of the boxes, and you'll find there are 25 boxes. The area of this square is 49 square units. What is the length of each side of the square? The area of this square is 49 square units. What is the length of each side of the square? Well, the length of each side is going to be 7 units. And then we can check that by 7 times 7 is 49, which of course is the area, 49 square units. The area of a square is found by squaring the length of one side. So here's the one side, S, and the area will be S squared. If you know the area and want to find the length of any side, then you will need to use an inverse operation. The numbers in the right column, it's over here, are squares of the numbers in the left column. If you want to undo squaring a number, you must take the square root of the number. The symbol for square root is called the radical sign, and it looks like this. So the numbers in the left column are the square roots of the numbers in the right column. For example, the square root of 81 is 9. When the square root of a number is a whole number, the number is called a perfect square. Since all the numbers in the right-hand column have whole numbers for their square roots, this is a list of the first 15 perfect squares. Here's our expression right here. The square root of the area is equal to the side. So the area of a square is 100 square units. That's over here. Since the square root of 100 is equal to 10, the length of any side of that square is 10 units. This can be verified because 10 times 10 is 100. So 10 units for each side, and the area is 100 square units. An inverse operation undoes an operation. It returns us to where we started. So, for example, subtraction is the inverse operation to addition. If we add 5 to a number and then subtract 5, we get back to the original number. Division is the inverse operation to multiplication. If we multiply a number by 7 and then divide by 7, we get back to the original number. We will explore an operation that undergoes squaring a number. Squaring a number is to multiply it by itself. So squaring 4 is to multiply 4 times 4 to get 16, or written just like this, 4 squared is equal to 16. An inverse of squaring would start with the square 16 and return us back to the original number 4. That operation is defined as taking the square root of a number. So the square root is an inverse operation to squaring. And once again, the symbol for the square root is the radical sign. So if you're given that 4 squared is equal to 16, it follows that the square root of 16 is equal to 4. Performing the operation and then the inverse operation returns us to where we started. In this case, the square root of 16 being 4 tells us that 4 multiplied by itself equals 16. Evaluate the expressions: the square root of 4, the square root of 49, the square root of 64, the square root of 1, and then the square root of negative 16. The square root of 4, we start with 4 is equal to 2 squared, or 2 times 2. So the square root of 2 squared, or the square root of 4, is 2. The square root of 49 is the square root of 7 squared. Therefore, the square root of 7 squared is going to be 7. The square root of 64 is the square root of 8 squared, or 8. Square root of 1 is 1 squared, and it's just equal to 1. And the square root of negative 16, we do not have a real square root.